All right, here we go. Welcome to chapter 7. This is a pretty meaty chapter, and this is kind of where, in a lot of ways, everything we've talked about before comes together, and risk treatment. So we're going to get on with it here. This is a pretty long chapter, so I don't want to dawdle. Risk treatment involves the selection and application of risk reduction measures for risk which is judged to be unacceptable. Excuse me. In other words, you've looked at all these risks and you ranked them all, and some of them might be okay, lower risks. There's nothing without any risk at all, of course. So now the ones that are unacceptable, you can look at them now and to do something about them, and that's risk treatment. It is the end result or output of the risk assessment process used to control the identified hazard and reduce its risk. Without acting upon the risk assessment's findings and treating a risk assessment is of no value, and in fact may lead to negligence of the organization. So in other words, if you know something about something is a problem or a risk, and you're not doing about it, that can be construed as negligence. So here you go. That's our good old step ladder of risks of process of risk management. We've done establishing and all this stuff. Now we're down here, the very last step, risk treatment. Now we're still going to cover one more subject, but monitoring and treat and review. But risk treatment is the last step in this particular process. The assessment here, the context, then you have these 3 steps of assessment and now treatment. That's where we're at. Let me move my head back up here. All right. The risk treatment is defined by ISO Guide 73 as the process to modify risk. For operational and hazard risks, the process to modify risk involves the selection and application of one or more treatment options to reduce risk to a level that is acceptable to the organization. ISO Guide 783 provides several notes, which we'll talk about the next 2 slides, that further describe risk treatment options. Risk treatment can involve, this note 1, avoiding the risk by deciding not to start or continue with the activity that gives rise to the risk. Usually that's done if you're doing prevention through design, really in the early stages of something, you say, okay, we're not going to do this. You're already doing it. It's a little harder to get rid of. Taking or increasing risk in order to pursue an opportunity. Removing the risk source, changing the likelihood, changing the consequences, and sharing the risk with another party or parties, including contracts and risk financing. You might want to be able to get a consultant in to do something, or rather, or a contractor maybe, or like insurance also, and retaining the risk by informed decision. In other words, it's there, but you're going to keep it. Note 2, risk treatments that deal with negative consequences are sometimes referred to as risk mitigation, risk elimination, risk prevention, and risk reduction. And some risk treatments that deal with negative consequences in safety, that's what we try to avoid, is negative consequences, but we deal with them. Such terms that we talked about are frequently used interchangeably, and do these terms mean the same thing? Well, we're going to take a look at it. Mitigation, generally defined as the action of reducing the severity of seriousness of something. Some definitions are the act of lessening the force or intensity of something unpleasant, the process of becoming milder, gentler, or less severe, to cause or become less harsh or hostile, to make less severe or painful, the effort to reduce loss of life and property by lessening the impact of disasters. Hazard mitigation is any sustained action taken to reduce or eliminate long-term risks to human life and property from hazards. Those are some various definitions for the term mitigation. Risk treatment terms: protection, shielding, covering, or keeping an asset from harm. Similar to risk mitigation, it does not prevent the event from occurring and is designed to limit the severity of harm. Examples are sprinkler systems, cathodic protection, which is protection from corrosion, for an underground storage tank, PPE. Insurance, which is a risk transfer, is also considered a protection measure for the insured properties or property. Prevention, the act of keeping something that would cause risk from occurring. It stops an event from happening. So it's different. Prevention is actually stops it from happening. Example is a pressure relief valve on a tank or vessel. Prevents overpressurization and potential explosion. Preventive actions are generally less costly than mitigating the effects after they occur, but may also be perceived as a waste of resources if the predicted event does not take place. Of course, in my opinion, the fact that it didn't take place is at least some indication, if not proof, that the preventive action worked. So, that's that's here where you get back into the things I've talked about before, where the accountants, the bean counters, and the engineers disagree. The accountants can tell you it's going to cost this much money, and the engineers can't tell you there's going to be a disaster, but they can tell you there very could be a disaster. Hazard or risk control, a more encompassing term meaning to manage risk by reducing likelihood and severity of an exposure. Okay, we all know what that does. Likelihood and severity. Do that on a risk matrix. You reduce them and you reduce the overall risk ranking anyhow. Also, to check, test, or verify by evidence or experiments. To incorporate suitable controls in a controlled experiment. To reduce the incidence or severity of, especially to innocuous levels. And the term innocuous just means not harmful or offensive. Risk reduction seeks to reduce the likelihood or severity of an unwanted risk. Reduction is the act of making something smaller in size, amount, number, etc. So all these terms address elements of risk treatment as risk reduction strategies. A comprehensive approach often requires a combination of prevention, protection, mitigation, and reduction measures. Risk treatment plans can involve a single control or multiple risk reduction measures to accomplish the risk reduction desired. Concepts such as inherently safe design, layers of protection, recognized and generally accepted good engineering practices, and safer technology and alternatives, along with a hierarchy of controls, should be incorporated into the risk treatment plan. Risk treatment options can include the decision to avoid the risk by choosing to not engage in the activity or exposure, eliminating the risk by removing the risk source, reducing the likelihood or reducing the severity, sharing their risk among other parties, such as contractors and risk financing, retaining the risk, such as self-funding or other risk-based decisions. So you can see, you talk about risk treatment options, and you can see where this is kind of leading them. Now I want to talk about RAGAGEP, recognized and generally accepted good engineering practices. It was introduced by OSHA in 29 CFR 1910.119, process safety management, which we're going to talk about later on, because process safety management is basically a huge risk management endeavor. It applies only to highly hazardous chemicals, which, if you think about it, that's really what we need to be protected from. RAGAGEP involves a selection and application of appropriate engineering, operating, and maintenance knowledge when designing, operating, and maintaining chemical facilities with the purpose of ensuring safety and preventing process safety incidents. As the reader can see, the RAGAGEP approach is in alignment with the PTD concepts, prevention through design, of designing in such measures and managing risk throughout a system's life cycle. It also comes in sometimes when there are no written guidelines, older equipment perhaps that doesn't have manuals, and that's when you also have to apply the RAGAGEP concept to that too. Safer technology and alternatives, one risk reduction approach for chemical incident prevention developed and implemented by industry and stakeholders is the promulgation of requirements for safer technology and alternatives, or STAA. The concept of safer technology and alternatives has been incorporated into both the U.S. EPA Risk Management Plan standard and OSHA's Process Safety Management Standard. STAA refers to risk reduction strategies developed through analysis using a hierarchy of controls model illustrated in the figure. Next slide. Now, this here, you can call it something different, but really what it is, it's you do hazard assessment and elimination, reduction, substitution, attenuation, simplification, engineering controls, administrative, PPE, where we heard most of those before. All basically this is applying the hierarchy of controls to reduce risk, and then you have a safer process. All right. So this is nothing new. It's just rewording and redoing it. So this doesn't just make a lot of sense to me. Just somebody's, oh, we're going to take this idea and make it look different because we need to put that in our thesis or something like that. So identifying risk treatment options. Once hazards have been identified and the risk assessed, proper risk treatment options are considered for selection and implementation. Okay, so we've identified the hazards. We've assessed them. And we've determined, okay, these are the most hazardous and that. Now we're going to do treatments. So this requires the risk assessment team or decision makers to determine the options available and their degree of risk reduction, reliability, and associated costs to implement and maintain. Feasible control options that may reduce or eliminate the risk from the identified hazards are identified using internal and external resources. Existing internal sources include the occupational safety and health professional, experienced stakeholders, and operators familiar with the hazard and control methods. Input from affected workers knowledgeable in the operation, equipment, or process is advised. You'll hear me talking about all the time. You want to find out about something about operation? Go to the person doing it. They know more about it than anybody else. And you have, and it's a good idea. Try to gain their confidence by showing that you're there for them, protect them, because they're the ones who are going to get hurt if something goes wrong. And so, and if you do that, they can realize that what you're going to do and help you out by pointing out things that the casual observer might not see. So, do never underestimate what these people know about that, because they know way more than you're ever going to know. Outside resources such as manufacturers' literature and engineering reports, OSH-related research from institutes and professional organizations such as ASSP and AIHA, regulatory standards and guidance, industry best practices, industry consensus standards, National Institute for Occupational Safety and Health publications are also available. NIOSH publications are generally pretty general in nature, though. But if you want to get something down to the nitty gritty, you want to go to your organization, your not organization, but the field that you're in. Like, for instance, the poultry safety conference every year we had. Great place to go and rub elbows with other people in the poultry process. Regulatory standards, of course, are always your number one thing, probably. Organizations ASSP, which is the American Society of Safety Professionals, used to be called ASSE, American Society of Safety Engineers, but most of them weren't engineers. So they changed it, which makes sense. Industry consensus standards are good. Find out what other people in your industry are doing. Professional, and don't ever count out consultants. They're usually pretty knowledgeable. Selecting risk treatment. The primary principle that occupational safety and health professionals should apply in the selection of risk treatment is the use of the hierarchy of controls model. All right. You might have heard that before, huh? Risk treatment selection requires a balancing of the overall costs and the financial and non-financial benefits, including legal and regulatory requirements. This requires some investigation into the suppliers of the risk treatment. Now, this would be something that's a pretty expensive risk treatment, not just building a guard for a couple of $100. This and associated costs, including purchase price, installation, training, maintenance, and service costs, as well as expected lifespan of the treatment. This is when you have something that's probably pretty involved, and the risk treatment is going to be something that's going to be pretty expensive and have to be purchased, installed, maintained, etc. So you need to find out what that's going to cost, by all means. And have to know the expected lifespan of the treatment and how long will the manufacturer stand behind it and fix it for free. How long will they guarantee it? Risks with extremely high severity potential but low likelihood may warrant risk treatment, even when the costs of the treatment are not justified in a typical cost-benefit analysis. How do you put a cost on somebody's life? So I think that's what they're trying here. High severity potential usually means if there's an accident, somebody or some people are going to die. But low likelihood. So that might not happen, and it might turn out to be a pretty expensive treatment. But if it has that severity to it, then you might want to do that treatment. When risk treatment is being considered in new facilities, equipment, etc., the concept of prevention through designing out or avoiding hazards should be incorporated by all means. Inherently safer designs that avoid bringing new hazards into the workplace or operations should be the first choice. Control measures that are built in or considered permanent are always preferred to those that are removable or dependent upon human action. I'm going to repeat that last sentence. Control measures that are built in or considered permanent are always preferred to those that are removable or dependent upon human action. Usually a guard is considered permanent. You can take it off, of course, but as general rule, it's only taken off in certain circumstances under pretty strict control usually. So that's usually, and it's always there. You come to work, you work on a machine, the guard's there. You don't have to do anything. Okay, it's there. Now, PPE, you have to put on safety glasses. That means that person's got to put them on. So that's a big problem in PPE right there. People just get so used to it. Oh, I've done it 1,000 times, nothing happened, and then it happens. So, selecting risk treatment. Care should also be taken to ensure any risk treatment selected does not introduce new hazards. affect the control of other hazards, or have unintended consequences, such as the use of hearing protection or on mobile equipment with backup alarms. Many times, multiple layers of protection are needed to reduce risk to an acceptable level. Interim controls may be needed while longer-term solutions are being developed and implemented. So interim controls can be enacted if you're in the process of developing longer-term solutions. The process of selecting risk treatment can be formed using a variety of methods, and it shows them down there. So I'm going to not dwell on them here because I want to talk about them. Selecting risk treatment. This provides brief descriptions of the methods available, and some of them we're going to look at. Guess what is number one on the hit parade? Hierarchy of controls. We all know what that is. We've had some exposure to it, and it is the most important thing, I think. Now, these are others: cost-benefit analysis, multi-criteria analysis, financial and non-financial benefits, business impact analysis. We're going to dwell on briefly, but cost savings, expanded return on how net present value, payback period, return on investment, internal rate of return. Those are all concepts we're going to look at. And your chances are, if you're going to get into some of those things, you're probably going to need some help from the accounting department, maybe because for costs, they're not available to you. Or maybe they are, but we'll look at some of those. But we're going to basically going to stick with as looking at this as if you're the safety professional at the place, and you're looking at the people, and the hierarchy of controls is probably going to be your biggest guide. So the hierarchy of risk reduction strategies. Risk treatment selection should always be linked to the concept of the hierarchy of controls to reduce risk to acceptable levels. Hazard and risk control measures vary in their degree of risk reduction, effectiveness, and reliability. The hierarchy of controls, which is usually abbreviated capital H, small o, capital C, is structured with the most effective and reliable options at top and descend down to the lowest level of protection. In descending order, the hierarchy model generally starts with avoidance of risk, excluded in some models, followed by elimination of risk, and then substitution of risk. From there, residual risks are controlled using engineering controls, warning systems, which are excluded in some models, administrative controls, and personal protective equipment. Now, the warning systems aren't excluded in the model that we're the basic one we usually use. It's just part of administrative controls. So they think it's excluded. Well, that verbiage is excluded, but the warning systems themselves are not excluded. So a variety of these models exists. I'm going to talk about a couple of them. Unfortunately, there continue to be OSH textbooks and professionals that refer to engineering controls as the highest level of control. I think you'll see sometimes that triangle with the multicolored triangle without substitution elimination at the top, cut off in just three. Because those are the reason for that is those are the three on a day-to-day basis that you're going to look at most of the time. It's important to recognize and understand the difference among various hierarchy of control models. Now, this is it, the one we've looked at a lot. And it's starts at the top: elimination, physically remove the hazard; substitution, replace the hazard; engineering controls, isolate people from the hazard; administrative controls, change the way people work; PPE, protect the worker with PPE. And this is from the NIOSH Prevention to Design Hierarchy Controls model. And we're going to just look at it. This is going to, personally, I like this one the best, mainly because it's really simple. It's 5 things, and they come right out and make a pretty succinct, clear statement of what they do. Elimination, physically remove the hazard. Now, again, some of them put avoidance above that, but avoidance is something that if you're avoiding it, it's not even, you don't even have it. So you just decided not even to bring it in. So there's no control needed in a way because you don't have it. So substitution, replace the hazard. Usually that's with chemicals. You can do it with like voltages or something like that too. But any time that I've ever seen it done, it's usually just a less hazardous chemical. Engineering controls, isolate people from the hazard. Of course, machine guards, the main thing there. Administrative controls, change the way people work. Of course, people have to be trained in it and they have to do it. PPE, protect the worker with personal protective equipment. And there again, the person has to put it on. That's a problem sometimes. And this is the hierarchy of risk reduction strategies. And what else is it called here? hierarchy of health and safety controls. They're calling this. Let me get my head out of the way. And we're not going to, anyway, we're going to look at each one of these. We're going to look at them here. All right. I'm just going to, that's the same chart. You can look at each one. Elimination, designed to eliminate hazards such as falls, hazardous materials, noise, confined spaces, and manual material handling. Substitution, substitute for less hazardous material. Reduce energy, for example, lower speed, force, amperage, pressure, temperature, and noise. Engineering controls, oddly enough, they say ventilation systems is the first one. Most people say machine guarding, and it's the first one. But they have machine guarding, sound enclosures, you could do that, put on something. Circuit breakers, platforms and guardrails, interlocks, lift tables, conveyors, and balancers. Warnings, signs, backup alarms, beepers, horns, and labels. And this one, and again, we would throw these into administrative controls. And they're calling them administrative controls procedures, safe job practices, rotation of workers, safety equipment inspections, changing work schedule, training, hazard communication training, confined space entry. Okay, under the safety equipment inspections, what do you think that involves? I'll give you an example. You got to be equipment, probably has e-stops on them. Does anybody ever check to make sure those e-stops work? You only use them in an emergency, right? Shouldn't most equipment, you don't use those to stop the machine, although some people do. But so what if do they all work? How do you know they all work? So periodically they should be checked. Personal protective equipment, safety glasses, hearing protection, face shields, safety harnesses and lanyards, gloves, respirators, and how about safety shoes, safety boots? So this is a little different look here. Hierarchy of risk reduction strategies. Instead of looking at this chart and trying to read all these little things, I'm going to look at it here one at a time. Now, this is elimination or substitution. I'm going to go backwards here a little bit. See what they've done here. They've got their risk reduction measures, examples, influence on risk factors, and a classification. And they're calling elimination or substitution design out. They're calling guards, safeguarding devices, and complementary measures, engineering controls, and everything else they're dumping into administrative controls. So let's look at them. Okay, all right, let's look at it. Elimination or substitution, their classification of designing out something. Examples, eliminate pinch points, increase clearance. Okay. Intrinsically safe, energy containment, automation, redesign the process to eliminate or reduce human interaction, reduce energy, substitute less hazardous chemicals. And then the influence on risk factors is impact overall risk elimination by affecting severity and probability of harm, may affect severity of harm, frequency of exposure to the hazard under consideration, and or the possibility of avoiding or limiting harm, depending on which method or substitution is used. So they're kind of putting these two, elimination substitution, together. So in elimination, of course, it's completely gone, so the hazards are completely eliminated, but substitution not. So that's why these two probably don't belong together. Guards, safeguarding devices, and complementary measures. These are called engineering controls. Example, barriers, interlocks, light curtains, safety mats, that type of thing. Two-handed controls and other enabling devices. And this should say guardians up here again. Engineering controls, the influence on risk factors of the engineering controls are greatest impact on the probability of harm, occurrence of hazardous events under certain circumstance, minimal, and if any, impact on the severity of harm. So the engineering controls generally have the greatest impact on the probability. Awareness devices, administrative control, lights, beacons, and strobes, computer warnings. Computer warnings are like if you have a big system and you have alarms that came up when something's not right and the computer beeps and lets you know about it. And too often in these systems, the warnings are too inconsequential. They don't mean anything. They're just, and they get to be a pain, and sometimes they get shut off or they just get ignored, and that should never happen. If they are warnings that come about too often, that should be looked at and maybe adjusted, and not warning until they're at a different level, because that happens way too frequently in these computerized systems. So beepers, horns, and sirens, signs and labels. The influence on risk factors, potential impact on the probability of harm, avoidance, and no impact on the severity of harm. So they're talking about, they're looking at risk factors being severity and probability. Training and procedures, their administrative controls, safe work practices, safety equipment inspections, training, lockout, tag out, verify. And I don't know what verify, I mean, it's you verify it every time you do it. On risk factors, potential impact on the probability of harm, but no impact on the severity. Again, more administrative controls, PPE, safety glasses and face shields, earplugs, gloves, footwear, respirators. Potential impact on the probability of harm, but no impact on the severity of harm. I'm not sure I agree with that, but that's the same one. Now, this one's in the book, Hierarchy of Risk Reduction Strategies, two-stage iterative approach, and it's there. Action steps, change task, function, location, etc. Substitution materials, eliminate it. So they're just saying eliminate one step, and everything else is the second step. Engineering controls, awareness, procedures, training, PPE. That's just, I just don't like that at all. I mean, I don't think these should be all lumped together. I think you should look at engineering controls and look at training and administrative controls. That's why I like the 5-step one. It's simple. And this is the PTD, the preventative design, hierarchy risk reduction strategies. And the reason why I'm going these different ones is I want you to get a look at some different things that are out there. I'm still going to stick with the 5-1, the triangle. I think that's the best. And but there are others out there, and you need to know that they exist, and you can use them if you want to. Again, this one says the first thing is risk avoidance. Well, prevent entry of hazards in the workplace by selecting and incorporating appropriate technology. That's something, though, that generally speaking, the safety people in the plant don't have a lot to say over. They should, maybe, but they usually don't. It comes in the plant, and sometimes that's the first I knew about it. And so risk avoidance, eliminate. Now they're saying you couldn't avoid it, so it's here. Now you have to eliminate it. And again, that's usually done in the earliest planning stages. Substitution, engineering controls, warnings. Here's the other, throw warnings in there. Administrative controls, PPE. So it's not a big difference. They have risk avoidance and warnings in there, and that's not a significant change. And this is a hierarchy of ergonomic risk controls. Again, you have avoidance, elimination, substitution, engineering, administrative, and PPE. So again, it's not any big difference. They threw effectiveness over here instead of the arrow or the shaded arrow coming down here on the other side. They have it over here. And so obviously, if you avoid it, that's pretty effective. It's not here or eliminated. That's pretty effective too. So they're all permutations of the basic concept. So of the 5-stage triangle. So risk treatment plans are risk-based decision-making. The objective of operational risk management is to implement appropriate risk reduction plans to mitigate risks associated with each decision made to achieve an acceptable risk level. OSH professionals should be able to effectively lead risk assessments, develop appropriate risk reduction strategies, and advise decision makers in making appropriate decisions. Risk treatments, risk controls, are designed to reduce the risk of a hazardous effect and to reduce the likelihood of its occurrence. A risk treatment plan should include options and alternatives that eliminate the risk or reduce risk. I don't even like the term risk treatment, I'll be honest with you. Why don't they just say risk controls? Risk treatment plan sounds like you're going to a doctor and going to give you a couple of pills and said, call me in the morning. The OSH professional should have an alternative plan as a secondary option to present to decision makers in the event the primary plan is declined. Figure 7.11 depicts the risk-based decision-making process in context to the selection of risk treatment options. And it says, identify decision, determine context, decision-makers, stakeholders, options, influential factors. Now you're going back to step 1 pretty much. Assess the risk, determine needs, select risk assessment tools, generate information, make the decision, evaluate the information, assess the options, select option based on risk, and monitor effectiveness. evaluate results, assess impact, make refinements, communicate results. Now, most of the time, you're doing these things without thinking about them, or without delineating them, or without, but and then communication and consultation at the bottom. I mean, it's everywhere. So that's the end of part 1 of chapter 7. So there'll be a part 2. It won't be as long as this one, I don't think. So in the meantime, between part 2 and part 1, be safe.